Welcome back to the continuing exciting story of C pointers. What use are pointers? In the previous slide, I hopefully managed to convince you, I tried to convince you, that pointers are perfectly simple and that they are just addresses of something in memory, and you can push stuff along those little pointers thingies that I've shown on the diagram and move data around in memory, because that's what you do in C. Okay, what do we actually use them for? Well, first of all, there's a fundamental theorem of software engineering, a FTSE, which says we can solve any problem by introducing an extra level of indirection, which is a sort of a joke, but it has a surprising number of examples when it's true. And pointers are a way of introducing an extra level of indirection. So what are they used for? Well, you've actually been using them all the way through your computing so far. When you wrote Python or Java, whatever you did, you were almost certainly using reference parameters all the time, or reference variables. Didn't call them pointers, but they were pointers. In Python, a dictionary contains a name and a pointer to the object. I should have said the dictionary that represents your local variables contains a name and a pointer to the actual variable. So those are reference things are pointers. So there's use number one as references. We'll also see them very shortly in dynamically linked data structures, things like linked lists and so on, which some of you will have covered in COSC 122. We'll see the real guts of linked data structures. The other use for them is the classic C use, which abounds all over the place. People like to write tricky looking clever code because they think they're being clever, or they think they're being fast or something. So often, because it's compact, you think it's fast, but actually it mightn't be. It's the case that compilers nowadays are very, very clever, but they can't be too clever with pointers because pointers can be pointing anywhere in memory, so it's very hard for them to optimize your code. So if you use pointers, you probably stand in the way of the C optimizer, and you may well finish up with less efficient code, and you will almost certainly finish up with less readable code. So I'm not encouraging use number two here, but I am going to use it because it's part of the C ethos, and we'll see some of it definitely. So let's look instead at how we can use pointers for reference variables. So we've already used them. Here's an example of a function, I'll just call it scanf, a function call which used pointers. I said you'd come to understand it shortly, and shortly has now arrived. This says call the scanf function asking for a decimal integer value to be converted and put in your variable I. That particular bit, %i, passes the address of your variable I into scanf in order that it can pass the value back into your variable I. It also returns a value, which in this particular case I'm ignoring, which is just like Henry Baker said, C language teaches you to ignore exception conditions. So I'm ignoring the exception condition. Naughty, naughty, but I'm going to carry on anyway. I'm going to write scanf. I'm going to write a very, very simple, crude, rudimentary version of scanf, and I'm going to call it myscanf to avoid confusion. I'm going to set its return type to void because I'm ignoring the return value, and I'm going to call it myscanf. And what does it take? It first of all takes a string. And we haven't really done these properly yet, so I'm just going to write, it takes the format char format array. So we kind of did that in the last week's labs. This is a way of passing the template, the format string across. I'm going to ignore that. I'm going to assume it says %d. Like I said, this is a very rudimentary version. And the other parameter, which is the important one, is going to be the pointer back to the user's, the caller's, data value, which I'm going to write as int star because it's an integer pointer, and I'll write it pi just to make the point that it's a pointer to an integer. Okay, what do? How do I write scanf? Scanf reads standard input. I'm going to assume that it's just going to read a sequence of digits. So I'm going to have an integer c in which to hold the characters I read. I'm going to have an integer num, which is going to be the answer I'm going to return, and I'm going to sit there in a loop writing something like while isDigit. Now there's a function isDigit. It's defined in ctype.h here, which I'd already put an include for. And I'm going to say, while isDigit, the character C, which I just read using getchar, and to keep the compiler happy, I'm going to put an extra level of brackets in, just to avoid warnings, because it looks dangerous. While the character that I just read is a digit, multiply the current value that I'm building by 10, and add in the new digit I just read, which is the character C minus the ASCII value for 0 in order to compute. This gives me clearly, if C is the ASCII character 0, gives me a 0. If C is the ASCII character 1, I get 1, and so on. I want you to think about that loop and see if you can, well, make sure you can understand it. You can pause the video now and ponder a bit if necessary. Then I'm going to return the value. How do I do that? Easy. I say star pi is equal to num. Now, this is a case where you may find the textbook notation a little bit easier to think about. If I declare star pi as a pi pointed to integer as being an int, then this makes sense. The left-hand side is an int, the right-hand side is an int, so that's the correct type. However, I still want you to declare pi as being pointed to an integer. Let's see what happens. Compile it, run it, enter a number, 23579, and it prints I as 23579. Whoopie-doo, my code worked. At this stage, I want to give you a bit of a challenge. I want you to try and write the code for a scanf that deals with percentage %x for hexadecimal, and then maybe for percentage %o for octal. Actually, try that first, it's easier. So what you just saw was a use of pointers as a way of passing data back into the caller. The caller provides its address. Here's where my variable I lives, and that allows the scanf function to put the answer at that place. And that's kind of it for pointers. There's another example here in the lecture notes, which again you can pause, and you'll have to do this in the lab anyway. The idea that you've got two data arrays and you want to find which one's longer, for example. And I've written a cunning little trick, which is a way of introducing you to an idea here. If I declare a data array, for example, I shouldn't do this, but down in this code here I say int data array is 10, 13, 4, 5, etc. And then I want to know how big it is. Obviously I can count myself, 1, 2, 3, 4, but then if I later add an extra value, my count of 4 will need to be changed. So there's a trick here, and that's to use the size of operator to find out how big the data array is, and then divide by the size of each element, and that essentially works out how big it is. It only works for local variables. Don't go trying this for parameters, formal parameters, not going to happen. And so this function goes through and swaps the values of longer and shorter, which are two integers, which are the sizes of the two arrays. So you think about that, you'll have to do it in the lab. I'm going to move on. No, I'm not, I'm going to stop. So the takeaways from that particular exercise are that the key aspect of pointers that I want you to get the hang of at this stage is for use as reference variables. Here I'm passing a reference to my variable I that allows the call E to pass back the value via the arrow like a so. So there's this picture. Actually, I should have explained the picture for you. It's right here in the lecture notes. Here's a picture of the main function, which has some saved stuff and a variable I. Here's a picture of my scanf, which has a pointer back to I, and when it computes the value, it's finished in this loop, it passes the value num by pushing it along that arrow, just like in the Binky movie. Thanks for watching. Bye.